All right, this video is to help you understand how to solve radical or root equations using basic algebra. And the nice part is, again, we're just solving equations, so it's not going to be anything fantastic. Basic skills from Algebra 1 are really going to pay off here. If we can take a good look at our equation, the biggest hint for most of these problems is going to be, as noted at the bottom, isolate the root if possible. Remember that x to the negative or to the positive half is the same thing as the square root of x right now. So if I add 9 to both sides of my equation, I end up with x to the 1/2 equals 6. Then I can quickly square both sides because 1/2 power being a root, the opposite of that would be squaring it. Also helps to think power to a power. 1/2 times 2 is just x to the first. But again, I also have to square the other side, giving me 36. Don't be afraid to take that number and check your answer for all the problems we do today. So 36 to the 1/2 power, again, is the square root of 36. That would be 6 minus 9. And 6 minus 9 is -3 with checks with the other side of the equation. My answer is x equals 36. Now, those can get slightly more difficult just by putting in more obstacles. So go ahead and take a second. We also have a cubed root here, so think about how you'd get rid of that. But take a second to pause the video now and see if you can solve these two equations. I'll put the answers up for you in just a second. All right. On the left here, you'll notice that I added 13 to both sides. -9 plus 13 gave me 4. Then to get rid of a cubed root, we're going to cube both sides of the equation. So cubed root cubed becomes x, and 4 cubed is 64. We can quickly check our answer just to make sure that with the back of the book, we also end up getting that same thing. So just a second here, and you'll notice we end up getting x equals 64, and that does work out. On the right, you'll notice I added 2, which gives me -3. To get rid of the the square root, I'm going to square both sides. So square root squared becomes 4x minus 7, just the stuff underneath, and -3 squared becomes 9. Add 7 is 16, divide by 4 is 4, and again, check our answer, and uh-oh, what happened here? Well, remember, when you square both sides of an equation, occasionally you put in more answers than are really there. Quadratics have 2 answers. Our equation might not have had that many. In fact, it had none, according to the answer key. So let's go back and check and see what happened. When you plug 4 back in here, 4 times 4 is 16, minus 7 would have been 9, square root of 9 is 3. Now notice over here, we had -3. So when we got +3 minus 2, we actually end up with 1 on the left side, but we needed to be equal to -5. Because we squared a negative number, it sort of broke the algebra. We didn't do anything wrong, but we created what we call, again, an extraneous solution. So we just label that EXT, and our actual answer will be that there's no solution. Thus, a great time to remember, check your answers. You can create answers that would have worked halfway through the problem that don't actually work at the very beginning. Don't forget to check your answers. Again, they create what are called extraneous, extra answers, and we don't like those. Not an answer that works in the original problem. Now, for a little more of a challenge, what happens with these? Notice here we've got 2 different roots going on in the same equation. The first thing I would notice, though, is that on the right side, there's just a 0. So to help us out, I'm just going to move that 2 root x by adding it to the other side. I can just say, well, minus 2 root x, I'm going to add that over to the right side, and now it's just a root equals a root. A perfect time, again, to square both sides of my equation and get 3x plus 2 equals 2 squared is 4, square root of x squared is just x. Subtract my 3x here, and 2 will be equal to x, which should give us a pretty good answer. Checking the answer key there, looks like it does work. Again, we also could have plugged our x back in ourselves and found out that 3 times 2 is 6 plus 2 is 8. The square root of 8 minus 2 root 2, well, remember 8 is 2 root 2. Square root of 8, if you break that down, is 2 root 2. So square root of 8 minus 2 root 2 just cancels itself and you get 0. Now on the right here, we do have a little more of a trick. I can't just add this stuff to the other side because that 4 is in the way. But that's not going to stop me. I'm going to do it anyway. Because the nice part is, again, my biggest hint, isolate the root. We've got that root practically by itself over here. Negative x plus 4. Then I'm going to divide by a negative 1 and create the fact that the square root of 2x equals x minus 4. Now is a perfect opportunity again to square both sides. Square root squared, I no longer have a root. Now if you remember how to FOIL out x minus 4 times x minus 4, well, you get your x squared. We'll get a minus 4x on both the front and the back, and then a plus 16 for the last term. So you'll get x squared minus 8x plus 16. Now that it's a quadratic, we're just going to solve for 0. Subtract 2x is a negative 10x plus 16. And if you throw that into the quadratic formula, or you factor it, or whatever method you would like to use, polyroots on your calculator is always an option. So let's go ahead and do that once. I'm going to go to my calculator, and I'm going to say menu. Well, polyroots, algebra, polytools, find the roots. And I'm going to look for when I've got a 1, negative 10, and a 16. So 1, negative 10, and 16. Go ahead and hit enter. We'll hit enter one more time, and you'll notice we get answers of 2 and 8. So our answers here are 2 and 8. And again, it would be a great idea to go ahead and check our solutions. Uh-oh, what happened if they're telling me only 8 works? Well, again, plug 2 back into the beginning. 2 minus the square root of 4, well, that should have been 0, not 4. So it looks like 2 was an extraneous solution, 8 worked. If we plug 8 back in there, 8 minus the square root of 16, 8 minus 4 is 4. Only 8 is a good solution. It can happen that you get 2 good answers, but again, check those answers and make sure you don't end up with extraneous solutions. Now, I just have a couple more quick examples for you. So if you want to try this problem here, go ahead and try it, and I will pause the video now, and I will work out the problem and show you what the answer is. All right, notice the thing I liked about this one, I had 4th roots on both sides. So I immediately just took the 4th power, and all the roots are gone. So now I've got 57 minus 4x equals 69 minus 2x. I'm going to subtract my 57 to the right, at the same time move my 2x over to the left, and finally, negative 2x equals 12, divide by negative 2, and I get a nice x equals negative 6. Now again, you should check your answers there. Because they're both 4th roots, all that really matters is that the radicand, the number underneath, comes up equal. So negative 6 times negative 4 would have been 24. 57 plus 24, negative negative, becomes a 81. So I've got the 4th root of 81 over there at the left, which by the way is just 3. And then on the right, 69 minus 2 times x, so 69 minus 2 times negative 6 becomes 69 plus 12, also 81. And again, 4th root of 81 equals the 4th root of 81. 3 equals 3. My answer checks. Again, one last example if you want to watch it. Feel free to try solving it first. I'll be right back with you in just a minute. All right, the first 2 steps are pretty simple. First of all, let's get rid of this 2. Let's not worry about the exponent until we have to. So I divided out the 2 and got 125 over there on the right. Then, if I'm to the 3/5 power, again, if I could multiply by its reciprocal, I can cancel off that fraction. Again, power to a power, if I take thing to another power, then I multiply them. So I'm just going to take the left side to the 5/3 power and the right side to the 5/3 power, giving me x on the left. Now I just have to think about what is a 5/3 exponent. Well, remember, 5 is still a power, but that 3 on the bottom is really the 3rd root of 125. 3rd root of 125 is 5, and 5 to the 5th then is 3125. Again, you can check that part on your calculator. That's a pretty big number. But if you check it out, again, 5 to the third obviously was 125, 5 to the fourth is 625, and 5 to the fifth is 3125. You can plug that back in, double check your answer, but again, I'm pretty sure it works. Good luck. I hope that helps you with solving equations, and have a great day.